This is a problem worked through for problem 116 in lesson 4.2, solving for the impulse using a numerical calculation method. In this problem, we have a 1 gram pellet traveling at 100 meters per second until it embeds itself in 2 centimeters into a pumpkin. What force does the pumpkin exert to stop the pellet? So as we start with our laundry list, let's start with the 1 gram pellet. Now, when we make our laundry list, we know that gram is a measure of mass. So we put 1 gram here. However, we know we need to automatically convert that into kilograms. So 1 gram is divided by 1,000 and we get 0.001 kilograms because that is the unit that we have to use in order to actually calculate for impulse and such. Now, this is traveling at 100 meters per second. So that is definitely a velocity, but we don't know if that will be our initial velocity or our final velocity yet. So we'll just hold off on that one until it embeds itself 2 centimeters into a pumpkin. Now, 2 centimeters is a distance. So we can write this down here. Distance is the variable x, and we'll write 2 centimeters. And even though we don't exactly know what we're going to need this for, 2 centimeters, we will never use centimeters in a calculation, so we need to convert this automatically to meters. So we divide by 100, we get 0.02 meters. Now, as we continue through the problem, what force does the pumpkin exert in order to stop the pellet? So that sentence tells us two things. One, force is our unknown. That's what we're looking for. And if the pellet is traveling at this speed until it is stopped in the pumpkin, that means that our final velocity is 0 meters per second, and this 100 meters per second has to be our initial. So we have a mass, an initial velocity, final velocity, and force. However, that means we also need time. Now, we can't have two unknown variables in our calculation. So we know that in order to solve the problem, we're going to have to use mass times the parentheses final velocity minus initial velocity, and that equals force time. We know that force is what we're solving for, so we're just going to go ahead, divide both sides by time. So our formula that ultimately we'll need to do is force equals m Vf minus Vi over T. Now, like we see in our laundry list, we have mass, we have final velocity, we have initial velocity. We don't, however, have time. So how can we find time? Well, that's where this piece of information comes in handy. So forgive my poor estimate of a pumpkin here. But if we have a pellet that is traveling that direction, when it reaches the edge of the pumpkin, it is still traveling at 100 meters per second. But as soon as it enters the pumpkin, it's going to start slowing down. Now it's only going to travel 2 centimeters in the pumpkin, at which point it is stopped. So even though we would normally think we could use velocity equals distance over time, this formula is not appropriate because it assumes a common velocity. It doesn't take into account the fact that as soon as this pellet hits the pumpkin, it's going to slow down. So if we can't use this formula, what we are going to have to use is distance equals final velocity plus initial velocity divided by 2 multiplied by time. Now, in most cases, we would want to isolate for time and then solve. But in this case, with this fraction component here, it's easier to just substitute our numbers in to simplify somewhat and then solve for t. So we would do it like this. X is going to be 0.02. Now, in this block, we've got our final velocity of 0. We've got our initial velocity of 100. and this is divided by 2, multiplied by time. Now, 100 plus 0 is still 100, so 100 divided by 2 is 50 t equals 0.02, which when we divide by 50 on both sides, 0.02 divided by 50 is 4 times 10 to the minus 4 seconds. Now that value, combined with final velocity, initial velocity, and mass, in this formula will give us our force. So we get force equals 0.001 kilograms is mass, 0 minus 100 is our velocities, and 4 times 10 to the minus 4 is our time. Now, just to be clear, we can rewrite this as 0.1234, right? So instead of writing it in scientific notation, you can write it like this, which makes it easier to punch it into the calculator. So if we do 0.001 times negative 100 divided by 0.0004, what we end up with is that our force is negative 250 newtons. All right. Thank you for watching.